Today's lesson is lesson number 4, and we are going to be focusing on solving equations with fractions. So our I can today is I can solve equations with fraction coefficients. So there's a fraction in front of our variable, and we're going to learn how to eliminate that. To start off today, though, you have a couple of review problems. These top two are solving equations reviews, and the bottom two are dividing with fractions. Remember, when we divide with fractions, we KCF. If you forgot what that meant, we keep, change, and flip. Hopefully that helps refresh your memory. Please pause the video, answer these 4 problems, and then come back to check your answers. If we go over these 4 problems, the first one, 7a equals 21. When you solve, a equals 3 because we are dividing by 7 on both sides. And notice I did remember to check my work. Second one, v divided by 5 equals 9. We have to undo that dividing by 5 with multiplication, and we get v equals 45. Checked my work, and it was correct. And then for those 2 dividing fraction problems, 1/2 divided by 5/6, I keep, change, flip. So if we look at this, I would keep the 1/2, change to multiplying, and I flip that second fraction as to flip the numerator with the denominator. When you multiply fractions, remember you multiply straight across, so you get 6/10. I see that can reduce. Divide 2, so I divide numerator and denominator by 2, and I get 3/5. And the last one, 5 divided by 2/3. I looked at this, and the first thing I noticed was 5 was in a fraction, so I put it over 1 to make it a fraction, and then I did the keep, change, flip process. When I multiplied straight across, I got 15/2. Can't reduce, but I can turn it back into that mixed number, 7 wholes, and then there's 1/2 left over, so 7 1/2. So for today, we need to think about how do we make 1? What can I multiply a fraction by to make 1? And so we have some examples. And so when I'm trying to make 1, remember, when we multiply fractions, we multiply them straight across. So I need to get the numerators when I multiply them to be the same as my denominators when I multiply. So 3 times something and 4 times something, they both need to create the same number on the top and the bottom when being multiplied. And so if I would do 3 times 3, that would give me a 9 on top, but I can't multiply 4 by anything to make 9, so that didn't work. So let's try the 4. If I did 3 times 4, that gives me a 12, and I can multiply by 4 by something to make 12 as well. 4 times 3 makes 12, and 12/12 really equals 1. So 3/4 times 4/3 is 1. If I look at this next one, 1/3 times what would also equal 1. Remember, we need the same number on the top and the bottom. Well, 3 times 1, 3, and I can take 1 times 3 to make 3. 3 and 3 would turn into 1. 1/3 times 3/1. If you've seen the pattern, 2/5, if I multiply by 5/2, 10/10, which is 1. And, 7. Remember, think of it as a fraction, so make it a fraction. 7/1, 1/7, 7/7 is 1. When you are multiplying by that fraction flipped over, these are called reciprocals. So I can take a fraction and multiply by the reciprocal to make 1 and eliminate it. So looking at this first problem, 1/5 times x equals 4. My goal is to get rid of this 1/5 right here. So what I like to do, just kind of like on the other page, I'm going to box it up, and I have to think, what will I multiply it by where it would eliminate it? Well, I'm going to do that reciprocal. 1/5 would be 5/1. 5's cancel, 1's cancel. I eliminated it. I'm going to do the same on the other side, 5/1. And so when I multiply 4 times 5 over 1, numerators get multiplied, denominators get multiplied. Remember that 4 is really 4 over 1, so I have x equals 20 over 1. We don't need to write that. We can just write x equals 20. Then we're going to check. 1/5 times 20, is it equal to 4? If I think about multiplication, I have 1 times 20, which is 20, over 5 times 1, which is 5. 20 divided by 5 is 4. 4 equals 4. It works out. My answer is correct. Next problem, 2/3 x equals 6. I have my line. I'm trying to figure out how I eliminate 2/3. I'm going to multiply by the reciprocal. 3/2. 3's and cancel. Same on the other side. 3/2. But remember, we need that denominator. So x equals 6 times 3, which is 18, over 1 times 2, which is 2. Well, I know 18 and 2. 2 goes into 18 evenly. X equals 9. But let's go ahead and check to make sure I did that correctly. 2 over 3 times 9, is that going to equal 6? Make my 9 a fraction. 2 times 9 is 18. 1 times 3 is 3. 3 goes into 18 6 times evenly. It works out. X equals 9. Our next question, 5/8 x equals 20. Once again, we're trying to eliminate that fraction. We have to keep it balanced though. Remember, multiply by the reciprocal. 8 over 5 to cancel. Do the same on the other side. 8 over 5. When I multiply straight across, I have x on the left. 20 times 8 is 160. 1 times 5 is 5. And I know 5 is going to fit evenly in there. I just have to figure out how many times. So 160. How many 5s go into it? 5 goes into 16 3 times, which is 15. 1 left over. Bring to my 0. 5 goes into 10 twice. So it's 32. And hopefully I did my math right, but I can make sure I did that right when I check. 5 over 8 times 32, is it equal to 20? Put that 32 over 1 and multiply straight across. 32 times 5, well 5 times 2 is 10. 15, 16, I have 160 over 8. Well, 8 goes in 160 20 times. 20 equals 20, yes it does. And last but not least, 3/4 x equals 1/2. I want you to pause the video and do this on your own, then come back and compare your work against mine. You'll notice that to get rid of that 3/4, I multiplied by the reciprocal of 4/3 on both sides. Make sure we always keep this balanced, so I did it on the left and on the right. Multiply those fractions, I got 4/6, so I had to reduce because they're both even. So I divided numerator and denominator by 2 to get 2/3. When I went to check, I did 3/4 times 2/3, multiplied my numerators and denominators together. Notice that 6/12 can reduce. They're both divisible by 6. And I got 1/2 equals 1/2.